Hi, today we are going to look at this particular circuit, which is extremely easy to solve if we were just to use nodal analysis. But, as an exercise and also against our better judgment, let's use mesh analysis instead. Why? Well, today we will be taking a look at supermeshes. When we try to do mesh analysis, you'll quickly realize there are some issues. Namely, these guys, the three current sources in the middle. They're a problem because each of these current sources sit in the middle of two loops that surround them. What do I mean by loops, you may ask? Well, these are loops, denoted by I1, I2, I3, and I4 respectively. So whenever I say loops, I also mean the current that flows through the loop, but it just makes sense in this context. Whenever we talk about loops, we're basically talking about the current that goes through it. Now, back to what I said earlier. The 1 amp current source in particular over here is sitting in the middle of I1 and I2, those two loops. Before I continue, ask yourself, which current, the current through loop 1 or loop 2, is benefiting from that 1 amp current source in between them? And don't worry if you don't know the answer to it, I'm going to explain. Okay, so after thinking about it for a second, you can see that the answer is I2. Now here's a graphical depiction as to what is happening. We can see the current loop spinning around, and I could argue that I2 is greater than I1, denoted by the loop spinning faster. And we can kind of see that makes sense because when the second loop hits the left wall, it is going up, and when the I1 loop is hitting the right wall, it's going down. So it's kind of fighting against the current source. So of course we know that I2 is getting positively affected by that, and that's basically the evidence to back up my claim. We know this conceptually, but how could we structurally formulate this in English? Well, I2 is going to be greater than I1 by exactly 1 amp. And in math terms, it would look something like this. This is a math equation. Let's stash away this equation for later use, and it'll be helpful for us later, but for now let's move on to I2 and I3. Let's do the same thing again. Now we see that the current through loop 2 is facing the same way as that negative 100 milliamp current, so the current through loop 2 spins faster. The current through loop 3, however, spins slower because it is being hurt by the current source. But wait, I hear you say, isn't that current source negative? Yeah, well, I'd just like to say that I'm going to completely ignore the fact that the sign is negative. We treat it the same as before. All that matters is that I2 is facing in the same direction as the current source. So I2 is greater than I3 by a magnitude of negative 100 milliamps. Read this again, read it twice, maybe 3 times, and you'll realize that the English makes absolutely no sense. But we don't care about English. Let's proceed with translating the English into a math equation anyway. So there we go, and that makes a little bit more sense, but let's go ahead and simplify. Now, what I like to do is have everything depend on one single variable, so let's go ahead and eliminate I2 in exchange for an expression solely in terms of I1. Alright, there we go. Now let's go ahead and just solve for I3, move it to the other side, and simplify. Now let's stash away this equation as well. Now that I've explained how to do it, it's your turn. You should probably get this answer correct, but no pressure. Try and pause and think about which current source is going to quote-unquote spin faster. Which loop current is being helped by the current source? And also, ignore the signs. We're looking at it at a purely graphical standpoint. Alright, here we go. Well, the answer is going to be the current through loop 4, denoted by I4, is facing in the same direction as the current source highlighted in blue. So it will be spinning faster. How much faster, that is? How many more amps will it be greater by? Again, as silly as it feels, we'll deal with the signs later, so we don't care about them. For now, all we're looking at is I4 going up or down, and is I3 going up or down? And we can see that indeed, I4 is going up, and I3 is going down, right? So therefore, in plain English, I4 is greater than I3 by a magnitude of negative 500 milliamps. Writing this out in math form would look like this. We can replace all terms of I3 in this equation with some terms of I1. So let's go ahead and simplify the equation. Simplify, and stash it away again. Now all the currents through every loop all depend on the currents through loop 1. You might be wondering why this was useful, and I'll show you why later, but it'll become very apparent in just a second. Now, I'll show you the supermesh. First, we disable all the current sources. When we disable current sources, we delete them from the circuit, turning them into open circuits. This concept is similar to how in supernode analysis, I disabled the voltage sources by shorting them. Again, they're technically there, They're wreaking havoc through the currents of loop 2, 3, and 4 after all, but they're just going to be invisible for now. Oh, and also, since this 100 ohm resistor is just floating and not really connected to anything, it doesn't complete the circuit, and therefore we can just remove it. And that's all. This is actually the entire circuit. The super mesh is just everything in here. One giant mesh that is formed from combining loop 1, loop 2, loop 3, and loop 4. And you can tell that this is a mesh because all of these loops and all the currents all depend on I1. So therefore, they're all friends with I1. In other words, it's a super mesh, if you will. Now let's write out the mesh equation, as if there's nothing suspicious at all. We use the current closest to a component. So for example, the current through loop 1 would just look like this. It is closest to that 10 ohm resistor, so we'll write that as our term in our equation. Okay, now the next term is I4, the current through loop 4, multiplied by the 5 ohm resistor. Now you'll see that I'm going to take the representation of I4 in terms of I1, and again, it will become very apparent in just a second why, but to satisfy KVL, we set it all equal to 0, and we can simplify everything, and you can see that we can easily find the value of I1. Simplify, and now we have I1. That's useful, right? Yes, of course it is, because now we know what I2 is. We know I2 is just I1 plus 1. We know I1, we can plug it in, we know I2. We do the exact same thing for I3, and guess what? We do the exact same thing for I4. So there we go, we know everything that there is to know about the circuit. Put everything back in, and we're done. Now, before I go, the negative for the current through loop 1 just means that it is actually not rotating in the clockwise direction. Instead, it's actually rotating in the counterclockwise direction. So we can just flip it and delete the negative sign. On that note, I leave you with this. The voltage drop across the 5 ohm resistor from the current through loop 4 and the voltage drop across the 10 ohm resistor from the current through loop 1 is the same. Think about why that is and leave your answer in the comments below. That's all for today. Thanks for watching. I will see you next time. Goodbye.